So again, the theme for all three of these mornings is don't lose the wonder of who God is. You guys, as you go through life, there are going to be tons of times when you're not going to feel God. Nasty things are going to happen to every single one of you. You're going to get sick. People around you are going to die. You're going to be betrayed and lied about. You're going to be mocked and ridiculed. Jesus said, in this world you will have troubles. And there's times where you're going to wonder, where is God? The last little stanza of the song we just sang was, God answers prayers. Well, guess what? Just like when you were a little tiny child and you wanted to eat sugar and candy all the time, and your parents said no, or you want to watch TV all the time and your parents said no, God is going to say no a lot of times because he knows what's good for us. So what do we hang on to in those times when God doesn't seem to be there? And there's going to be a lot of those times in your life. The fact and absolute reality of his awe. And there's no other possible explanation for why you even exist. That's why this is so important, because you're not always going to feel him. But if you think, love the Lord with all your heart, all your soul, all your strength, and all your mind, you'll come back to realizing he is there. And he's the one who made you, and he cares about you more than you can imagine. You know, the man who suffered more than any person in the history of humanity, Job, he lost it all. Every bit of his wealth, every bit of his family. His wife left him. His health was gone. He was in absolute abject misery, screaming out, why is this happening? God never answered him. In the whole 40-some-2 chapters of Job, God never answered, why is this happening to me? Job doesn't answer that question. What God does was spend the last 6 chapters giving a creation lesson. Look at what I have made. Look at who I am. Look at my characteristics. Look at my power. Look at my care for everything. Trust me, trust me, trust me. That's the answer. And that's why this is all so important. Now, we're going to continue to look at life, the awe and complexity of it. I'm not trying to turn you all into scientists, but some of these things will come back to you at the right point, and realize when you're hearing stuff that contradicts what God's word has to say, it's leaving stuff out. And always ask yourself, what am I not being told? When you hear and you go off to college and you're reading National Geographic and you're going through museums, it's all being presented from the perspective, let's explain the universe, the box. Let's explain life. Let's explain everything as if it made itself. Naturalism, natural processes did it all. Now here's the first enormous problem people never get to hear about in normal public education. All of life is made from little machines that are irreducibly complex. Even the parts of a cell, the parts of a body, the parts of every organism, hundreds of thousands of little machines that won't work unless all the parts are there. Now, all evolution can do is change a little piece at a time. It can't just make a whole complex machine all at once. And we look at the mousetrap as an example. How many parts make up the mousetrap? But I need interaction. I need to know you're awake this morning, this early. Any guesses? Look at it. This is not a trick question. If you're going to build a mousetrap, how many different parts do you need? Exactly. Very good. You need the platform to attach it all to. You need a spring. You need a hammer that's going to come snapping around and hit the mouse. You need a little thing that will hold the hammer back, and then you need this catch that will hold the little trigger. 5 parts. There's only 5 parts. Now, if any part is missing, it will not work. It's a worthless piece of junk. And each of the parts are specifically designed intelligently to create the whole working mechanism. Now, we're going to look at several examples of that as we go along. All of life, every cell, every machine in every cell is irreducibly complex. Now, we looked at this one a little bit yesterday. Most bacteria have a little spinning hair called a cilia, and it is run by a literal electric motor. And this electric motor has about 40 different proteins that turn into these parts of exact shapes and sizes to make a motor. One of those parts attracts a positive charge, another attracts a negative charge. They repel each other, and they cause the thing to spin. It can spin at 10,000 rotations per minute. Very few motors we have spin that fast. And it can stop in 1/4 turn. Nothing mankind has ever made can do that kind of, achieve that kind of ability. And then it can reverse itself. Now, I didn't show this yesterday. I want to show a little motor of the latest bacteria that was found. It has not just one of these motors, but at the base of this bacteria, it actually has 7 motors. Each motor is attached to one of those purple gears. But to get them all to turn at the same speed in unison, 21 other little gears are attached to the purple gears. Now just think about this. This is a bacteria. This is the simplest form of life. And down there at a microscopic level are 7 little motors with 21 gears, all causing the motors to rotate and turn in perfect unison to create a little propeller, so these bacteria, by the trillions in our body, can swim around and find whatever nutrients they need and go in the right direction and go forward and reverse. Think of the complexity. At the very beginning of all creation, we find that sort of complexity. By the way, my PowerPoint kept locking up yesterday, and I think it was the embedded videos, so I pulled them out of the PowerPoint. And again, last little bit of review, those motors are so small, you could look at a single grain of sand and line up 10,000 of them across the width of a grain of sand. Again, humanity can't make anything remotely close to this. Now, how does evolution explain where did even one of those motors come from? This is what they do. They say, well, you know what? Those motors are made of proteins. They're like little complex molecules. We'll talk about proteins in a second, that bend and twist and fold to form a really specific shape. You know, like this shape would be created by one protein, the hammer would be created by another protein, the spring would be created by a third protein. Well, there's 40 proteins in this little motor. They found maybe 6 or 8 of them, same proteins, in other creatures, in other animals, in other bacteria that don't have the little motor. So they say, well, see, the proteins just kind of gathered themselves from other places, and over millions of years, they slowly, because it was an advantage, formed and turned into that motor. And students hear this, and they become convinced. Now again, I want to show a little video. This is a creation scientist. He's a biochemist. He has spent 20 years of his life. Think about this. Every day he comes into work, he goes to a laboratory, he starts studying bacteria. Day in, day out, week in, week out, month in, month out, year after year after year. For 20 years, he's done nothing but study the motor of that bacteria to try to figure out, could it have made itself? So I kind of edited it down to about 3 minutes. I want you to listen as he describes, could the parts have come together, because we found a few of them, to have created the motor? Because that's what you'll read in the textbooks as they talk about, well, things aren't irreducibly complex, the parts could come together. So let's watch that little flagellum creation motor and think about what's being said.
Scott Minnick has studied the flagellar motor for nearly 20 years. His research has led him to challenge the co-option argument.
With a bacterial flagellum, you're talking about a machine that's got 40 structural parts. Yes, we find 10 of them are involved in another molecular machine, but the other 30 are unique. So where are you going to borrow them from? Eventually, you're going to have to account for the function of every single part as originally having some other purpose. So you can only follow that argument so far until you run into the problem of you're borrowing parts from nothing. But even if you concede that you have all the parts necessary to build one of these machines, that's only part of the problem. maybe even more complex, I think more complex, is the assembly instructions. That is never addressed by opponents of the irreducible complexity argument.
Studies of the bacterial motor have indeed revealed an even deeper level of complexity, for its construction not only requires specific parts, but also a precise sequence of assembly.
You've got to make things at the right time. You've got to make the right number of components. You've got to assemble them in a sequential manner. You've got to be able to tell if you've assembled it properly so that you don't waste energy building a structure that's not going to be functional.
Building a molecular machine has been compared to the construction of a house, where workers follow a detailed blueprint and plan for assembly. The foundation of a house is poured before the walls are erected. Plumbing and electrical fixtures are installed prior to enclosing the walls of the structure. Windows must be hung before siding is applied, and shingles are attached only after plywood sheets are nailed to the rafters. So it is with the construction of a flagellar motor.
You build this structure from the inside out. You are counting the number of components in a ring structure or the stator. And once that's assembled, there's feedback that says, okay, no more of that component now. A rod is added. A ring is added. Another rod is added. The U-joint's added. Once the U-joint's at a certain size and a certain degree of bend, about a quarter turn, that's shut off, and then you start adding components for the propeller. These are all made in a precise sequence, just like you would build a building.
To build a motor correctly requires a complex system of machines that coordinate the timing of the assembly instructions. But how could natural selection construct such a system?
The co-option argument doesn't explain this. You see, in order to construct that flagellar mechanism, or tens of thousands of other such mechanisms in the cell, you require other machines to regulate the assembly of these structures. And those machines themselves require machines for their assembly.
If even one of these pieces is missing or put in the wrong place, your motor isn't going to work. So this apparatus to assemble the flagellar motor is itself irreducibly complex. In fact, what we have here is irreducible complexity all the way down.
We know a lot about the bacterial flagellum. We still have a lot to learn, but we know a lot about it. And there's no explanation for how this complex molecular machine was ever produced by a Darwinian mechanism.
There's no explanation for how evolution could have made that. None. Zero. None of it works. Don't lose the wonder of what God has done. The deeper we look, the more amazing it is. It's mind-boggling on the level of a little cell, the kind of stuff we find there. Whoops, wrong one. Now, let's look at a few other examples. I did this on one of the evening sessions. By the way, everybody in the school, all you students are going to get this book. It's in the back. The adults are getting it to give to others and read. But every day of the year, it's got a different example like that flagellum motors on one page. This is on April 25th. It's another page. They'll arrive next week, and your teachers will give them to you. But it's that way of keeping the reality of what God has done in front of you every day. And it's just really short, just one page each day of the year, about biology or geology or astronomy or physics or relativity, all sorts of sciences tied to Bible verses. But this is the article on April 25th, and I know most of you weren't there in the evening, so I want to repeat it. There's an insect out there called the leafhopper, and I like to call this guy the Olympic track and field gold medal winning athlete of the insect kingdom on steroids. Because nothing jumps like this dude. His whole body is built to drive those rear legs forward and cause him to jump. Now, the little baby doesn't weigh much, the nymph. So when he jumps, he can move much faster than the adult. He actually takes off at 100 times the acceleration of gravity. He literally disappears. When the little insect jumps, he's there and then he's gone. He's moving at like the speed of a bullet. He's just gone. He's that fast when he takes off and jumps. Now, to give you a perspective, what's 100 G-forces? What is that? Who knows? So I wanted to illustrate it visually. Astronauts, when they're going through testing, they want to make sure, can they take the acceleration to get out of the Earth's gravitational field? And you have to move at about 12,000 miles an hour. That's all really, really fast by the time they reach their peak acceleration. So they test them in centrifuges. They send them around and around faster and faster and faster to see, are they going to black out or can they handle this? This is what 10 times the acceleration of gravity looks like. Okay? It's a lot. You can smile, guys. It's hilarious. This is how fast they're moving with 10 G-forces. Now, this little insect, he takes off at 100 Gs, 10 times faster. It's a lot of force, a lot of speed. So scientists want to figure out, how does he do this? But there's a problem. The leafhopper's walking through the forest. He's dum-de-dum-dum-dum-dum-dum, and his little brain says, jump. Well, that signal has to go from his brain down his back. It has to go to his right leg and his left leg. And there are little protein muscles that will contract and cause him to propel forward. The signal has to reach them. We know how fast the nerve signal moves. We know how fast those little proteins have to contract to get him to move at 100 G-force. And it is impossible for that signal to reach both legs simultaneously fast enough so that one leg won't end up reacting faster than the other. In other words, he's getting ready to jump, and one of his legs is going to shove off before the other leg at the speed of a bullet. Is he going to go in a straight line? No. Everybody knows this. You're all shaking your heads. But at the speed of a bullet, he's going to go sideways, and his head is going to smash into a tree. Brains are going to go flying all over the forest. Dead leafhopper. No more evolution. So scientists are curious. That's what we do. We look at things we don't understand. We try to figure them out. So they dissected him. They looked at the little guy, the nymph, under an electron microscope, and this is what they found deep down inside the insect. 2 perfectly formed gears. Those weren't made in a machine shop. Those are inside of a stupid little insect. Now, one of those gears is attached to his right leg. One of those gears is attached to his left leg. And the gears are interlocked, so if one of those legs starts to move, both legs have to move in perfect unison. Now, someone who believes in evolution, they've left God out of their thinking, whether they're a Christian or not, they're leaving God out of their thinking as they look at this. They've been trained as a biologist to think without thinking, has God done this thing? They're thinking evolution's a fact, millions of years, billions of years. They'll look at that and they'll say, wow, look what evolution did. They think they've answered it. They'll tell the students, see, those gears are really useful, and they've allowed the legs to move in unison. So over a long period of time, evolution caused something that wasn't a gear to turn into a gear. And the students will hear this, and they'll say, wow, that's really cool. Anything can happen with lots of time. We'll talk about that in a moment. So they think they've answered it. But if I was to say, wow, look what Bobbity Boop did, have I explained where those gears came from? I've just thrown a word at it. Throwing the word evolution at this creation doesn't explain it unless the mechanisms of evolution actually work to explain it. You see, to create a gear from an insect that didn't have a gear, you'd have to start off with, I don't know, inside of some insect, there might be a couple little round tumors or just, chunks of protein. But they're not going to be gears because those are perfectly designed to operate in a certain way. So how do you turn something that's not a gear into a gear? A mutation is a random change. It's like taking something that's not a gear and hitting it with a hammer. Yeah, you're going to change it, but what's it going to do? Is it going to turn it into a gear? How about if I hit it a bunch of times? How about if I do it for thousands, hundreds of thousands, millions of years? I just keep hitting it and hitting it. Mutation, 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 mutation. Yeah, I'm going to form some little ribs, some little ridges. But if those ridges aren't perfectly aligned, they're just going to lock up. The leg's not going to work. The animal's going to die. If they're not exactly the right length, they're not going to fit together. The legs are going to lock up. The animal's going to die. If there's not exactly the right number of them, if they're not exactly the right length, if they're not exactly the right angle, if they're not positioned exactly right, the legs are going to lock up. And then the gears have to be linked to some sort of a mechanism to pull them forward, some sort of the muscle. And there has to be a linkage, some sort of a cable. And there has to be a nerve attached to it to send the signal from the brain to the muscle that's attached to the gear that's attached to the ligament point. And the brain has to know what to do with this new piece of equipment. If any of it's missing, the gears are just a useless piece of junk that's going to cause the legs not to work. You see, it's irreducibly complex. Everything has to be there in perfection or the animal dies. It's impossible. There's no possibility a little one change at a time could create this. And cells are filled with thousands of these examples. This is just one. See, God wants the truth to be known of his existence, and these are the ways he makes it known. I'm going to jump past this just because I want to get on to some other stuff. Well, you know I'm not. It's just fun. It's only going to take a second. Harvard, this is November 2nd out of the book you're going to get. Harvard research scientists decided they want to find out how smart is a bee. Now again, a bee's brain is about the size of a grain of sand. Okay, it's about the size of his brain, not much bigger than that. So it's a pretty dumb little animal. And they thought, let's see how intelligent it is. So what they did, they put a bunch of hives out there, and then they put a really rich food source about 50 feet away, or maybe it was, I forget, it's in the book, 100 feet away. And then they timed how long will it take the bees to find the food and go back and get the other bees to come find it. Well, they did this. It turned out it only took them about 5 minutes. So the bee goes, it finds the food source, and then, this is so cool, it comes back and it does this little dance. It wiggles its butt and does a little dance in the middle of the beehive. What's it doing? Turns out it is telling the other bees exactly what direction to fly and how far to fly to find the food source. They've studied this for years, and the direction in which it wiggles tells it the orientation of which to fly. How many times it goes around in the circles tells it how far they have to go to find the food source. And the angle changes with the time of day because it lines up with where the sun is at. So it constantly is changing its communication depending on the sun to tell the other bees where to go find food. Kind of cool. And within 5 minutes, they're all out there gathering food. So then the researchers moved it 200 feet away. Got the bees back in the hive, moved it 200 feet away, let them go. Again, within 5 minutes or so, they had found the food source. They moved it a third time, so it's 300 feet away. Sure enough, it only took them 5 minutes or so, and they found the food source. Then they moved it a fourth time, 400 feet away. While the researchers were studying the bees were studying the researchers. And they were already there waiting for them to show up with the food. They had calculated the direction each move had taken, how far each move went, figured out where the next move was going to be, and they were all there buzzing around waiting for them to show up with the food. Isn't that cool? The bees outsmarted the researchers with their grain of sand brain. That's what God has done. That's what he's done throughout the world, so we will be in awe of who he is. And biologists will say, wow, look what evolution has done. Doesn't explain any of this. How did those bees know when this other bee came back and started doing this little wiggly dance that it meant something? Probably thought he had epilepsy. No, it couldn't mean anything unless it was programmed into their little bee brains from the moment of creation. The world's filled with these things. I'm going to jump. Well, the sea iguana, there's so many examples. This is June 7th. This guy lives in the Galapagos Islands, which are surrounded by sharks. And these guys make a really tasty little hot dog meal for the sharks, just the right size for a tidbit bite. They love eating the iguanas. And their hearing is so good, they can literally hear the heartbeat of the iguana. They'll swim with the current, which sounds just like moving water, but the heartbeat's going boom, 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 boom. And the sharks will hear it, and they can tune right in on them. So the iguanas need to go out to eat, but the sharks are going to eat them if they go out to eat. What are they going to do? Turns out they shut off their heart when they go into the water to go swimming. They just turn it off. For 45 minutes, They'll swim around and collect food and eat. Then they'll crawl back up on the land and restart their heart. Want to try that? Shut it down and see how long you survive. We can't shut it down, and if we could, we would die. There has to be hundreds of changes of the chemistry and metabolism of this animal in order to do that. How could he have changed his whole body to survive without that flowing oxygen to his brain and move and function without his heart? It's the only animal that we know that can do this. Where did that come from? And how did it learn? The first iguana says, oh, I'm going to get eaten if I go out there with the sharks. I better shut down my heart. Oops, haven't figured out how to restart it. Dead iguana. The wonder of what God has done. Don't lose it. Don't lose it. Okay, I'm going to jump past this guy because I really want to get on to some other stuff. I can't. These are so much fun. This is the last one. The bar-tailed godwit. This guy's really named cool. He's named after God. I think there's a reason, because no bird in creation does what this bird does. Turns out, loves to summer in Alaska, because I think it gets kind of hot down in the tropics, and that's where he lives most of the rest of the year. So in the spring, he flies along this route up through Australia. He goes all the way to New Zealand, way down below Australia, flies up here and stops, and then it takes a couple of days, flies to Japan and stops, and then flies up to Russia and stops, and then ends up in Alaska, and spends from June to September in Alaska. Then it's got to fly back down, or it's going to freeze back down to New Zealand. Well, turns out that's a 7,000-mile flight over open ocean with nowhere to stop. It has to fly continuously for 5 to 7 days without ever stopping. Can't stop flapping its wings, can't rest, got to stop continuously. It is burning an enormous number of calories, 7,000 miles, nonstop flight. No other bird does this. It's the greatest migration known to man. Now, in order to do this, it's got to store energy. It's got to have a lot of energy. So it gorges itself before it leaves for its flight. And its weight increases 55%. And it stores it as fat. What our bodies do too. They store stuff as fat so that they can make this long flight. And it's a special kind of fat that contains almost no water. It's a really solid, concentrated energy source. Again, very few other animals have ever been found that make this kind of fat. So, but there's a problem. It now looks like the Goodyear blimp, okay? It ain't gonna fly too well because it has to store all this fat. So it shrivels up all of its internal organs. Its liver, its heart, its stomach, its intestines, all of them shrivel up to almost nothing. So the fat can then take up that space and it becomes more streamlined again. If it wasn't able to do this, it wouldn't be able to fly far enough to reach there. If it wasn't able to do this and eat as much as it ate and make as much fat, it wouldn't have enough energy to fly all the way there. If that fat wasn't a super concentrated, low water forming fat, it wouldn't be able to store enough to fly all the way there. All this stuff has to be there or it's going to die. It's going to crash and burn and land in the ocean and be dead. So it streamlines itself and flies all the way to New Zealand nonstop. That couldn't happen a step at a time. Everything has to have been designed and created for this animal to happen. Now, all of this happens because all of these abilities and all these parts and all these pieces of our body are essentially made of a chemical called a protein. Now, let me show you, I'm going to back up a second. Let me show you what a protein looks like. A protein is made of a bunch of little beads. You see there's a bunch of different colors here. You know, there's clear and blue and pink and green and red and purple and chartreuse and orange. And there's actually 20 different beads that make up the proteins of all forms of life. They're called amino acids. And way, 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 way back early in history, according to evolution, there was an experiment done. I just thought since, you know, I would sit here so you could hear a little better. Where in 1952, a researcher put together methane and ammonia. He had an explosion, boom, and he created a few of these little beads. Now, your eyes are shut, so I'll show them to you again. And supposedly, because this guy in 1952 made these little beads, that shows how life could have formed millions of years ago here on Earth. Now, there's a whole bunch of things that were left out of that experiment I'll show you here at the end. But let me show you what one typical protein that makes up the parts of every form of life looks like. Okay, this is a typical protein that's inside of our cell. Like there's 40 of these that made up the electric motor. Okay, so here is a single protein. Every single color, every single amino acid has to be in exactly the right spot. There's a disease called sickle cell anemia. If this were hemoglobin, which carries oxygen in our blood, the beads are in the right position with the right of the 20 different amino acids in the right spots, so it will bend and twist and fold in just the right way to carry oxygen in an optimum way. And if one of the colors is misplaced, it's just switched with another color, one mistake, the whole thing then gets messed up and it doesn't bend quite right. The hemoglobin molecule, instead of being round and holds a lot of oxygen, it becomes flattened out and sickle-shaped. The average age that someone lived to at the turn of the century who had sickle cell anemia was 3 years old. They would die by the time they were 3. Today we have blood transfusions and various medicines that help, so the average age is about 40. And they have all sorts of joint pain and problems and all sorts of, they have a fairly miserable life because of one mistake on one molecule. They all have to be absolutely perfect. Now, could evolution, it's this faith that evolution could create this incredibly perfect molecule all by itself. So we're going to do an experiment. We're going to try to use evolution to make a very, very simple protein. Now, the protein we're going to try to make is, Pastor Boyd, could you grab a big box? The big, under there, there's empty boxes. I need the big one, the big square one. This particular protein, it has to have a red amino acid here, and it needs to have a white amino acid here, and a blue amino acid here, and then there has to be a yellow one here. Whoops. Come back. No, there's a big square one I need to hold all these, and then a green one. So we're just trying to make a really simple amino acid, or a protein, which has 5 different colored amino acids. Now in the bag, and we're going to put them in a box here in a second, I have almost 20 different colors. So out there, supposedly in the past, there were amino acids floating around. That's the one I was looking for, thank you. And random chance supposedly lined them up to make the right protein to turn into life. That's what I need. Thank you very much. That was the big square one. So we're going to put our little amino acids in the box, and then we're going to add all the other random amino acids of life. Now, I need 2 volunteers. Okay. I used guys yesterday, so I'm going to use 2 girls today. 2 volunteers, right here. Two girls raised your hands. Thank you. Now, one of you is going to be evolution. Who wants to be evolution? Oh, you get to be evolution. Well, evolution's blind, so you have to be blind. Okay. Now, what you're going to do, you are going to stand. We got to get here wherever you can see it. Okay, come on up onto the stage. Pastor Boyd, would you cover up, put something in front of the projector? Just here, place this. Yeah, place that piece of paper. Well, actually, I need that piece of paper. Here, put the book. Okay. So, Miss Evolution. Okay, I need you, the helper, over here.
Wait.
Who's Evolution? Your Evolution. Okay, what's your name?
Rachel.
Rachel, okay. Rachel, what you're going to do, I'm going to put the blindfold on you. You're going to kind of reach down in here and randomly grab an amino acid. And then you're going to hand it to?
Allie.
Allie? To Allie. Allie, you're going to be over here. Okay. And Allie, you're going to place whichever amino acid that blind chance grabbed in the first position. And then, Miss Evolution, you're going to reach and grab another amino acid, hand it to Allie, you're going to be blindfolded, and she's going to put it in the second position. And you can do this fairly fast, and then you're just going to line them up, 1, 2, 3, 4, 5. What you're going to keep track of, and I'm going to give you a piece of paper, How many times, we'll do all 5 and then we'll start over again. Dump them back in, we'll start over again. How many times does she get all 5 of them correct? Random chance. Then you'll start over again, number 2, but you'll also write down how many times does she even get one amino acid in the right position. So does she get them all right? Does she even get one of them right? And then we'll try it again and make a little hash mark. So, sorry, I was rushed getting ready. Anybody have a pen? Thank you. All right, here we go. Evolution in action. So all correct, and make a little hash mark, or 1 correct. And then total tries. Okay, bang, bang, bang. Okay, you are about to be, here, you can put it on. Yep, you throw those back in. And kind of reach around, because there's almost 20 different colors here, and grab, okay, I'm gonna position you. Okay, position in front, okay. Okay, grab one, and go kind of fast, don't take a lot of time, and just kind of line them up. Okay, while they're doing that, let me tell you what the odds are. You see, if this is how proteins were made, if this is what caused life to happen, there's 20 different amino acids. Only on average, 1 time out of every 20 tries is she going to get the right amino acid in the right spot. Remember, if even one of them's wrong, it's the wrong molecule, we're going to die. Life isn't going to form. So she's got to keep trying. Evolution's got to keep trying. It's got to keep trying. To get the first one right, followed by the second one right, will happen once every 20 times 20 tries. That's once every 400 times. To get just 3 letters of a protein, 3 amino acids in the right spot, would happen once every 8,000 times that they try. 4 amino acids, once every 160,000 tries. To get all 5 of those right, guess how many times she's going to have to stand here and try, and then retry, and then retry, and then retry. It would happen once every 3 million times. The average protein, are you guys listening? I know you're watching too, but you're listening. The average protein in all of life has 300 perfectly aligned amino acids, 300. The one I showed you was about 3,000. Some of them are 50,000 long, and they're all in the right position. Now, I'm going to ask you a question. All around us, there are people who believe in evolution because they're told it's true. Now, I know you guys aren't some of them, but your job as Christians are to influence the thinking of the other people and line them up with the truth and show them the awe and reality of the Creator. You know what the answer always is? Well, if there's enough time, anything could happen. If the universe is infinitely old, anything could happen. Well, let me ask you, this is a perfect response for someone who believes in that. If you, with your hard-earned money that you've worked really hard to earn and you've got out there to have a job, if you could buy a lottery ticket and it costs $10, but only one person on the entire planet Earth, one person out of 7 billion people was going to win, would you risk your $10 to take a chance of being that one person? Raise your hand if you would. So, a lot of people would. Forget about not being gambling and not being a gambler. This is a hypothetical question. Think of the amount of money you would win. You would win trillions. Would you risk $10 on a 1 in 7 billion chance? Anybody? Okay, good. 2, 3 of you? 3 of you. Hey, it's just $10. Now, just leave it to me here. How about if the odds were 7 trillion for a trillion years? Generation after generation after generation, for a trillion years, only one person out of 7 billion was going to win. Would you risk your $10 to be one of that one person out of a trillion times a trillion? And now would you? Why? Because you don't have enough faith you could possibly be the one. You don't have enough faith that could possibly be true. You know, a trillion times a trillion is 1 with 24 zeros. For one protein to form, average protein, 300 exactly lined up amino acids. That would happen once with every one with 400 zeros after it. You wouldn't even risk $10 on the belief you could win with 1 and 24 zeros. When I started to calculate this number, I went on the web to look for a scientific calculator, and I did 20 to the 300th power. Every calculator I could find just came up with infinity, too large to calculate, too big. In other words, impossible. It's an impossible number. It's more atoms than there are in the entire universe, multiplied by a trillion times 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 a trillion seconds. And you still don't get to one with 400 zeros. And that's one protein. The simplest form of life is like the mousetrap. Every protein is specific with specific parts. It has 1,000 different proteins, all forming little molecular machines, all of them perfect, all of them designed where any single mistake in any single amino acid wouldn't allow it to be formed. Okay, girls, last one for evolution to have given it a try. That's it? Yeah. Okay, what is the total? Did she, in how many tries? Okay. So let me just, were you putting a hash for every ball that was put up there?
Yes.
Here, so let's divide by 5. You got 5, 10, 15, 20, 25, 30, 35, 40. You got 8 tries, about 8 tries. In 8 tries, she never got all of them right. She got one color in the right position 8 times. So 8 times she got one color right. It's worthless. It will do absolutely no good. It won't become anything that's of any use in any biological molecule. It can't happen. It's an absolute impossibility. So we're going to end there. We're going to continue tomorrow talking a little bit about life, and then we're going to talk about the geological record and dinosaurs and fossils and how all that fits in. But in every area of science, it's the same answer. None of this is possible by an evolutionary viewpoint. It's a scientific impossibility. And the folks who believe in it, they put their trust in odds that are so absurd and so ridiculous that none of you would risk any of your money to believe in it. And yet the world around us just accepts it as if it's true. See, that's a way of making it real to people. What are the odds? What are the chances? What are the statistics that it could be true? And based on what we know, it couldn't. It's a way of helping people understand what you have is a faith, but it's a faith far, far more, and I hesitate to use the word, but I'm going to use it, ridiculous than the faith that there's a creator behind it all. You know what I forgot to do? I forgot to have you take off the blindfold and said, okay, now line it up and make the correct ordered protein with the blindfold off. And you all know she would have did it in a matter of seconds. Because with intelligence, you can design things very easily. But the intelligence needed to make an electric motor so small that you could put 10,000 of them across a grain of sand is beyond even our comprehension. That's the God who made us. Don't lose the awe. Thank you.
God bless you guys.